Yellowstone Supervolcano, complicated plumbing of hot springs and steam vents that are found in the national park. I should say so. It's got over 60% of the world's geysers and over 10,000 hydrothermal areas. This is the latest on Caldera Chronicles. We've also had a tremendous amount of eruptions from Steamboat Geyser, the biggest geyser in the world. This is Yellowstone Caldera Chronicles, the weekly column written by scientists and collaborators of Yellowstone Volcano Observatory. This week's contribution is from geologist Pat Shanks, scientist emeritus with the U.S. Geological Survey. Past issues of Caldera Chronicles detailed the various types of thermal features at Yellowstone, and we've also covered the chemistry of the springs, which leads to different styles of hydrothermal activity. But what happens when you start mixing these different compositions? And what happens when the different types of hydrothermal activity overlap? Exploration and sampling of Yellowstone's thermal areas indicates that Yellowstone's hot springs are often have surprisingly complex plumbing systems. And because of this, it's not uncommon to find hot spring pools and steam vents, also called fumaroles or vapor-dominated vents. Fumaroles is a vent from which steam and volcanic gas issues. The vents are an opening at the Earth's surface through which magma erupts or volcanic gases are emitted, one or the other. So vents, fumaroles, or vapor-dominated vents located in close proximity or even occupying this same exact space. Beryl Spring in the Gibbon River Valley, south of Artist Paint Pots, is a good example with a strongly and constantly boiling hot spring pool with a beautiful fumarole just behind the pool. Beryl Spring waters have temperatures ranging from 90.5 to 94.2 degrees Fahrenheit. 92 is about boiling at Yellowstone elevation, so you can understand it is boiling, and near neutral pH, and relatively high dissolved chloride content, Cl. The fumarole, on the other hand, contains 98.9% steam. The remaining gases are mostly carbon dioxide with minor hydrogen sulfide. Now, why did the two completely different types of vents occur so close together? The answer relates to the hot spring fluids that have circulated deeply in the hot rocks of the Yellowstone subsurface and become heated, and therefore they become buoyant. As the hot fluids ascend and pressure decreases in the near surface environment, boiling occurs and steam plus gases separate from the fluid. Steam may remain entrained in the ascending fluid as bubbles, or it may find a separate pathway to the surface through cracks or other conduits. At Beryl Spring, the fumarole has found a separate conduit that vents close to the main hot spring. But steam vents that have found other pathways dot the hillside above Beryl Spring and follow a fault zone on the Hilltop Monument Geyser Basin, which is about 0.8 kilometers, that's about half a mile, from Beryl. Then you have the Monument Geyser Basin. It's an area of dozens of steam vents with very low chlorine and acid pH between 1 and 2.5. Sulfur gases such as hydrogen sulfide in steam vents generally create acid conditions because reactions with oxygen produces sulfuric acid. This results in strongly acid pH in the 1 to 4 range. No high chlorine vents occur in Monument Geyser Basin because of its elevation, about 800 feet above water table at the Gibbon River. So only steam rises to this level. In some cases, steam condenses to form acidic pools that may be clear frying pans, quote unquote. They're shallow pools with steam bubbling through that resemble hot grease in a skillet, or more often mud pots with clay minerals from acid rock alteration. So steam vents may be closely associated with hot spring pools or may vent separately but the steam and fluids often have a common source. In some cases, steam vents occur within hot spring pools, resulting in fluid mixing that has profound effects on fluid composition and especially pH. Imperial Geyser, near Midway Geyser Basin, is a clear blue pool with a steam vent right in its edge. Surrounding the pool is an active mud pot area to the west. The quiet hot waters, about 85 degrees Fahrenheit, in most of the pool have high chlorine and alkaline pHs of 9 to 10, but pH measurements taken near the steam vent give acidic values of 3 to 4, similar to the mud pot fluids outside the pool. In this case, the geyser erupts frequently, up to about 30 feet high, due to the steam vent that entrains water from the pool. The water in the pool has chlorine, about 200 milligrams per liter, but is not as high as some alkali Cl pools. So this is a case where steam and gases have separated from the liquid water on ascent to the surface, and the steam finds multiple pathways to the surface, including venting in the mud pot area and in the pool itself. A final and broad-scale example where the interplay and interaction between acidic steam vents and alkaline chlorine fluids in hot springs is at Norris Geyser Basin. Norris is one of the most active and dynamic thermal basins in Yellowstone, and hosting the world's tallest geyser, we know Steamboat Geyser, and the world's largest acidic geyser, the Etchinus Geyser. Perhaps the most unusual geothermal feature of Norris is the presence of many hot springs with chlorine and low pH. This is sort of the opposite of what would be expected, since high chlorine is usually associated with neutral or alkaline pH, not acid pH. Many hot springs at Norris are a result of entrainment of the acid stream into chlorine-rich fluids in the surface, especially in areas like Porcelain Terrace, where there are numerous fumaroles, perpetual spouters, and springs with acidic pH between 2.6 and 6.1. The acidic pHs are related to acid-forming H2O reactions with oxygen, producing relatively high sulfate content in the resulting hot springs. Now, even though the hot gases and waters expelled at the surface in Yellowstone's hydrothermal areas may share common sources, the way they arise on the surface can result in very different chemistry and manifestations, unraveling their histories, and can be especially complicated when fluids recombine at the surface, but chemical analysis tells the tale. Here we are at Yellowstone Volcano Observatory on the Caldera Chronicles. I'll leave a link below for you for this. This is a beautiful picture of the Beryl Springs strong boiling blue pool, about 25 feet wide. Here we are. And contains high chlorine liquid water with a near neutral pH. And immediately behind the pool, right here, Beryl Spring, behind the pool is a loud hissing fumarole producing a white cloud of steam. Loud and hissing. They usually hiss and whistle because of the very tight opening. And when it's like a pressure cooker or a teapot when it's boiling. When the steam comes out of the little hole from the teapot and starts whistling, telling us that the hot water is ready. So this is it, Beryl Spring. You have the pool and you have the fumarole. And this is the view of the Monument Geyser Basin looking northeast. Dozens of steam vents. You can see them right here. Look at the view of the Monument Geyser Basin. Okay. Steam vents occur in this area and form fumaroles, frying pans, and mud pots, and in some cases have built silica-rich monuments which lend the basin its name. It's an isolated area dominated by steam vents. Okay, this is not snow, this is the actual mineral that's covering the area. And you can see that the trees, of course, there's a tree kill as well. And this is a beautiful picture of the Imperial Geyser looking south. Aerial view. This hot spring pool is about 100 feet across. It contains alkali chlorine waters with a steam vent in the pool. The steam vent here is in the pool. And mud pots outside the pool area. And porcelain terrace, the area of Norris Geyser Basin. Note the steam vents in the foreground. And many milky blue silica depositing pools in the distance. Right here, for example. Here. I don't know if that's one, but maybe back there. Beautiful. This is all such beautiful, very strange, mystical, beautiful landscape and scenery. Milky blue silica depositing pools in the distance. The broad area of white deposits is silica sinter deposited, in this case from acidic chlorine-rich hot spring waters. So that's the very strange makeup and complicated steam vents and hot springs plumbing in Yellowstone. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.